In this lesson, we will be graphing in factored form of our functions. So what we need to do is when we are graphing, we are going to graph all of the x-intercepts or y-intercepts. We need to know what our end behavior is, and then we will need to decide about our turning points. For example, on number 1, if we have 2 roots or factors, we know that this would be to the second power. We know that this is even, and since our leading coefficient is positive, we're going to make a sketch to know that this is going to be a parabola opening up. The process is that we're going to plot the points that are given to us as our solutions. So if x minus 2 is one of our solutions, our factors, we're going to set it equal to 0, and we know that positive 2 is one of our roots or zeros. We have x minus 4 is equal to 0, setting that factor equal to 0 and adding 4 to both sides. We know that positive 4 is one of our solutions, our roots. So as we graph positive 2 and positive 4, we need to make a table that would give us 1 point on the left side of our graph, 1 point in the middle, and 1 point on the right side of our graph. Then we would be able to get the general shape. So picking 1 point, 1 x value to the left, I could use positive 1 x value in the middle, which would be positive 3, and 1 x value to the right, which would be 5. Then I simply substitute those values into my original equation so that I can find the y values or the f of x values. So if I plug in a 1, I would have 1 minus 2, and I would have 1 minus 4. So that would be negative 1 times negative 3, which would be positive 3. Now I'm going to plug a 3 in. So 3 minus 2 and 3 minus 4. 3 minus 2 is 1, 3 minus 4 is negative 1. We would have 1 times negative 1, which would be negative 1. Now I'm going to substitute a 5 into the equation. And so I have 5 minus 2, and I have 5 minus 4. So I have 3 times 1, which is 3. Then I'm going to plot those points on my graph. So positive 1, positive 3, positive 3, negative 1, positive 5, positive 3. Then I know that I have a parabola, which is opening up, and it is positive. Let's go on to the next example. So we know that we have a function that is to the 5th power. So this is going to be odd. We know that we have a positive leading coefficient. So an odd function with a positive leading coefficient is going to have this general shape. We have 2 factors, which we're going to set equal to 0. And we're going to find those solutions. So we are at positive 3 and negative 1. And now what we're going to do is we're going to make a table so that we will have 1 value to the left. I'm going to use negative 2. 1 value in the middle, I'm going to use positive 1. And 1 value on the right, I'm going to use positive 4. And I'm going to plug those values in, and then I'm going to draw my function. It doesn't matter the values that you pick, although you probably do want to pick values that are close to the ones that you have. It'll be most important to get the shape. So we have 1/5, and then we'll plug in negative 2 minus 3, and that's going to be to the 3rd power. And then we have negative 2 plus 1, and that's going to be to the 2nd power. So we have negative 2 minus 3, which is negative 5, and then negative 5 to the third power is going to be negative 125, and then negative 2 plus 1 is negative 1. Negative 1 squared would be 1. So we have negative 125, and then we multiply that by 1/5, which is dividing by 5, and so we get an answer of 25, and it's negative. Now we're going to put a 1 into our equation. So we have 1/5, and then we have 1 minus 3 cubed, 1 plus 1 squared. So we have 1/5. 1 minus 3 is negative 2. Negative 2 to the third power is negative 8. 1 plus 1 is 2. 2 squared is 4. So we have negative 32 divided by 5. So negative 32 divided by 5 would be negative 6 2/5, or 0.4. All right, now let's plug in a positive 4 into our equation. 1/5. Then we have 4 minus 3 to the third power, and 4 plus 1 squared. So we have 1/5. 4 minus 3 is 1. 1 to the third power is 1. 4 plus 1 is 5. 5 squared is 25. 1/5 times 1 times 25 would be 5. So we know that we can't graph negative 2, negative 25, but we know that that would be very far down, almost off the graph. Or it will be way off the graph, but we know that we can go down in the left section. Then we have positive 1 and negative 6 2/5, so just below that. And then we have positive 4, positive 5. So we know that this is steeply coming up. We're going to wrap around down here, up, and put our arrow on the other end, and that is our shape for our function. Okay, example number 3, we're going to do the exact same thing. We know that we have a power of 2, a power of 1, and a power of 1, which means this will be to the 4th degree, the entire polynomial. And we know then that because there are 4 exponents, this will be to the 4th degree, which is an even power. And our leading coefficient is 1, so it's positive, so it'll be some sort of parabola shape opening up. Now we set each of our factors equal to 0 to find our solutions, which are our x-intercepts. So we'll graph positive 1, positive 4, and negative 1. Then we're going to make a table that is going to help us to find the other points. Now, because we now have several sections, we want to do 1 point to the left, 0, which is between the first 2 points, 1 point to the right of the second point, and 1 point to the right of the last point. Now we're going to take those values and plug them in. So we have negative 2 plus 1, which is going to be squared, negative 2 minus 1, and negative 2 minus 4. Negative 2 plus 1 is negative 1. Negative 1 squared is 1. Negative 2 minus 1 is negative 3, and negative 2 minus 4 is negative 6. Negative 6 times negative 3, times 1 would be 18. Now we'll plug in a 0. So we have 0 plus 1, which would be 1 squared. 0 minus 1 is negative 1, and 0 minus 4 is negative 4. 1 squared is 1. Negative 1 times negative 4 would be positive 4. Now we're going to plug in a 1. 1 plus 1 is 2, and we're going to square that. 1 minus 1 is 0, and 1 minus 4 is negative 3, but because anything times 0 is 0, we know that that's going to be at 0. Now we're going to plug in a 5. 5 plus 1 is 6, so we have 6 squared. 5 minus 1 is 4, and 5 minus 4 is 1. 6 squared is 36. 36 times 4 is 144. So that is quite large, and that'll be off the graph. All right, so when we're graphing, we have -2, +18, which is way off the graph. We have 0, 4. We have 1, 0. And we have 5, 144. Looks like I made a mistake. We probably should have put a 2 in here instead. So I'm going to figure that out right now, because I picked a number that was exactly one of the answers. So if I put in a 2, 2 plus 1 is 3. We have 3 squared. 2 minus 1 is 1, and 2 minus 4 would be -2. So we'd have 9 times -2, which would be -18, which is going off of the graph. So when we draw this graph in, we have -2, +18, which is going to be way up. So we're going to come down and connect. And then we have 2, -18, so that's going to go way down and come back up, and then go very steeply off the graph to +144. So that's what a picture will look like. It does open up like a parabola, but there's also a lot of bumps in it as well. So I would like you to try example number 4, and we will go through that in class together, remembering that you're going to set each of our factors equal to 0 to find the roots. Then you will create a table of finding the points on either left and right side and in between the other points, making sure you know what the degree of the function is, as well as what the ends will look like.